Today, I'm going to discuss with you inverse trigonometric or circular functions. This topic is not included in your quiz 1, but it is included in your quiz 2. Remember, we have 6 trigonometric functions. Now, these 6 trigonometric functions are not one-to-one. No? Trigonometric functions are not one-to-one. Were I able to record this? Okay. Are not one-to-one. Remember the definition of one-to-one? Graphically, a function is one-to-one if every time you intersect it by a horizontal line, the graph of a function, it is intersected in at most one point, okay? So that means for every output, there corresponds exactly one input for a function to be one-to-one. As I said, trigonometric functions are not one-to-one. Therefore, they don't have inverses. So these don't have inverses. But if we are going to restrict the domains of trigonometric functions, their respective domains, we can make them one-to-one and hence can have inverse functions. So again, if the respective domains of trigonometric functions or circular functions are to be restricted they can be made one-to-one. And hence, can have inverses. So let's start with inverse sine function. So let's say given y equals sine x. So if we're going to restrict this to the domain, let's say x is between negative pi over 2 to pi over 2, then this is now a one-to-one function. Of course, this is not the only interval for which you can make y equals sine x one-to-one, no? So, but most of the mathematicians, actually in all books, no, they agreed on this. So, to come up with a one-to-one function. But as I said, You can have any other interval as long as will satisfy the definition of one-to-one, then you can have. But guaranteed that if you restrict your x to this interval, y equals sine x is one-to-one. So its inverse function is given by, so inverse is given by y is equal to cosine, sine of what? Sine of, with superscript -1. So it is read as inverse sine of x, or you can write the old notation, y equals arc sine of x. Now this is true if and only if cosine y, sine y, sorry, if and only if sine y is equal to x for all y that is between -pi/2 to pi/2. Okay? So remember, if you have y equals sine x as our function, having this domain becomes the range in the inverse function. And its range, which is -1 to 1, becomes the domain of the inverse. Okay? So the domain of this y equals inverse sine of x or y equals arc sine of x is given by -1 to 1, happens to be the range of y equals sine x, and the range is this agreed restricted values for y, happens to be -pi/2, this closed interval -pi/2 to pi/2. If you have questions, you just cut to me. So, or you just raise your hand. Is it possible to raise hand here? Is there any feature that you can raise hand? Okay.
Pero you need to look at the
Yes, Machi Pontillas. Any question, Matthew?
I know pa, I was just showing pa.
Okay. So graphically, for sine function, y equals sine x with restricted value between -pi/2 to pi/2, the graph is given by this. Okay, so y okay. So this is -1 input to, -pi/2, no? Our input is -pi/2 to +pi/2. So we are going to restrict on this set of values. So if your x is between -pi/2 to pi/2, the graph of y equals sine x becomes like this. So let's say this is -pi/2 1, and this is pi/2, -pi/2 -1, the corresponding value for y. And here, if this is 1, y, so the x value is pi/2. So the graph is something like this. So that is how the graph of y equals sine x looks like. So we restrict to this graph, no? Okay, this is actually half cycle, no? If you're going to look at this half period, because the period of sine function is 2 pi. This is just pi interval. So that is already 1-to-1. So hence, it can have an inverse. So for y equals inverse sine, y equals inverse sine of x, or y equals arc sine of x, the graph is given by y, and this is x. So you will have here -1 to 1. Remember, the range of this, which is -1 to 1, becomes the domain in the inverse function. And the domain of y equals sine x, this restricted domain, so which is the subset of the actual domain, becomes the output, no? And output values. And the graph of the inverse is given by this. No? When x is -1, the value of y is -pi/2. If your x is 1, the value is pi/2 for the output. So this is how it looks like. Going to this, and then going up. Okay? Yeah. Of course, if you continue this, it will be sinusoidal along the y, while the original y equals sine x is sinusoidal or periodic along the x. So that's the graph or the inverse sine. By the way, before, if you mean function, so it was written capital letter, capital A for the arc sine or capital S for the inverse sine of x. But it is not anymore being practiced, no? If you mean it function, we normally write it small letter, and associations of mathematicians decided on this, no? Whether capital or small, so we mean it function. Okay? Unlike before, that if it was written in small letter, we mean it relation, meaning for every input you can have one or more outputs. But now, whether small or capital, so every time you input x, so the output, for instance, for inverse sine x, just between -pi/2 to pi/2. Okay? One input, one output. Okay, so let us have examples. So let's say we are asked to evaluate, number 1, this inverse sine of negative, sorry, let's start with positive, +1/2. So your question is, what is that angle when I take the sine, it will give you a ratio of 1/2. So that is 30 degrees in radian measure. Because sine 30 is 1/2, sine 30 degrees. Or in radian measure, this is in degree measure, pi/6. Okay? Yeah, pi/6. So if the argument in the inverse, So this is our x. If x is equal to positive, the value corresponding to sine inverse of that is in the first quadrant. If negative, it is in the fourth quadrant. So acute but negative. Okay? So meaning the rotation is clockwise. Number 2, if I have arc sine of negative 1/2, so what is that angle? Acute negative in the fourth quadrant, that when I take the sine, it is negative 1/2. So it is negative 30 degrees or negative pi over 6. Okay, guys? Number 3. What about inverse sine of, or let's say, inverse sine of square root of 2, negative square root of 2 over 2. So since negative, we have negative acute expected. So that is equal to negative 45 degrees. Because if I take the sine of negative 45 degrees, I will get negative square root of 2 over 2. Or that is negative pi over 4 in radian measure. Or as a length of an arc directed, negative pi over 4. Okay? So number 4, if I have sine inverse of negative 1, I get negative pi over 2. Because if I take sine of negative pi over 2, it is negative 1. Okay, guys? Any question here? So if you're given a decimal like 0.8, and if you take the sine inverse of that, you can approximate using your calculator. You can have it in radian measure or in degree measure. In case there is no whether it is degree measure or radian measure, you are free to have. No, you can have it in degree or in radian measure. Okay, let's have another one. Another function, inverse function. So letter B. So for letter B, we have inverse cosine function. To get the inverse cosine function, we consider the trigonometric function y equals cosine x. Restricting this to an interval, the value of x to an interval of 0 to pi this time. So I think all authors of Trigo book agree on this interval. But of course, you can have any other interval so that it becomes 1-to-1. But this is what is used. Okay? Conventional, ito yung ginagamit. 0 to pi. First quadrant and second quadrant. So if you draw the graph of y equals cosine on this interval, so it is 1-to-1. Its inverse is given by y, which is equal to cosine with superscript -1 of x. So which is read inverse cosine of x, or its old notation, y equals arc cosine of x. Okay? So this is true if and only if cosine y is equal to x for all y that is between 0 and pi. Okay, guys? So remember, the domain of y equals cosine x becomes the range of y equals cosine inverse of x. And its range the range of y equals cosine x is the domain of cosine inverse of x. Okay, so the domain of cosine inverse of x is -1 to 1, and the range, of course, the agreed interval, which is 0 to pi. Okay, guys? So we now have the graphs, no? Let's compare their graphs. Graphically, for y equals cosine x on the interval 0 to pi, the graph is given by this. Okay, guys? So this is, let's say, negative pi over, we restrict it on what value? 0 to pi, no? I think we need to adjust. So here, 0 to pi. Let's say this is pi. So this is pi over 2. And let's say this is 1, 1. And this is -1. When x is 0, cosine 0, 1. When x is pi over 2, cosine of pi over 2 is 0. When x is pi, cosine of pi is -1. Okay? So we now have this. This is the graph of y equals cosine x on the interval 0 to pi. Of course, if you continue that, it is periodic and you will generate the whole graph of the cosine without restriction. But because of this restriction, this is now 1-to-1 and can have now an inverse. So, and the inverse of this is graphically given by cosine. So mathematically, cosine inverse of x, or y equals arc cosine of x so the graph is given by this. No? So the domain of y equals cosine x, which is 0 to pi, this restricted domain becomes now the range, and the range of y equals cosine x, which is -1 to 1, is now the domain, no, of the inverse. Okay, guys? So this is x, this is y. So let's make it a little bit longer. Ay, sorry. Oh, it disappeared. So this is y, this is x. Let's say this is pi. At the middle is pi over 2. And the graph is, let's have this. If x is, let's say, 1, you have cosine inverse of 1 is, let's say x is 1, cosine inverse is 0. So the point is here, for instance. If x is 0, cosine inverse of 0 is pi over 2. If x is pi, I mean negative 1, cosine inverse of negative 1 is pi. So negative 1, somewhere here, pi. Okay? So we now have this graph. Yeah, and then goes like this. So that is how the graph looks like approximately. If you go continue along the y, it is periodic, but it is not anymore function. It is simply a relation if you do that. But with this restriction, for y, negative, I mean 0 to pi, restriction for y, then it is now 1 to 1. No? So, and then for the x, negative 1 to 1. Okay? So that's the graph for inverse cosine. So let's say we're given this. Y equals, number 1, cosine inverse of positive 1/2. If we have cosine inverse of positive 1/2, so what is that angle? If I take the cosine, it is equal to 1/2. So that is 60 degrees. Or that is pi over 3. Okay, guys? Number 2, cosine inverse of negative 1/2. What is that angle? If I take the cosine, it is negative 1/2. Since it is negative, we take it from the second quadrant. Remember, the range for inverse cosine is 0 to pi, no? If negative, between pi over 2 to pi. So the reference angle, 60 degrees. So what is that angle in second quadrant? First reference angle is 60 degrees. So that is 120 degrees. Or that is 2 pi over 3. Okay? What about number 3? For number 3, we have cosine. So let's say arc cosine of negative is square root of 2 over 2. So what is that angle? If I take the cosine, it is negative square root of 2 over 2. So ask yourself first, what is that angle whose cosine is square root of 2 over 2? So that is 45 degrees. So that makes, that gives us the reference angle, but we want it in the second quadrant. So 135 degrees, or that is 3 pi over 4. Okay? So that's 3 pi over 4. Number 4. What about arc cosine of of 1? What is that angle? If I take the cosine, it is equal to 1. So it is 0 or 0 degree. Okay? So that's it. No? Any question, guys? So you can check, no? To make sure you take the, let's say, you have, after getting the angle, you take the cosine. But be sure it is in the restriction between 0 to pi. Otherwise, so you don't get the correct output. Okay, so let's have letter C. This time inverse tangent function. So given this trigonometric function y equals tangent x. So again, this is not one-to-one, but restricting x between negative pi over 2 to pi over 2, it is now a one-to-one function. Yeah. So you can have other interval to be a one-to-one, but this is the agreed or the conventional, no? So that everybody will have the same angle when you take the inverse. So the inverse function is given by y equals inverse tangent of x, that is how we write it, or y equals arc tangent of x. If and only if, so this is true if and only if tangent of y is equal to x. For all y that is in the interval negative pi over 2 to pi over 2. So notice that this is similar to the restriction for inverse sine, no? Except that we don't include the endpoints here because tangent at negative pi over 2 and at tangent pi over 2, this function, tangent, is undefined there. So we don't include negative pi over 2 and pi over 2. So again, what's the domain? The domain of y equals tangent x is the set of real numbers. So that becomes what? The range for the inverse tangent. So the range now becomes negative infinity to positive infinity for the inverse tangent. Okay? And for the range, for the domain, I think I have inadvertently interchanged it. The domain is the range of tangent, no? Anong range ng tangent? So that is negative infinity to positive infinity. Yun ang magiging domain dito. Yung range niya. At ang range ng y equals tangent ay, ang domain is negative pi over 2 to pi over 2. Yun na ang magiging range naman here. Which is actually yung agreed interval, no? Itong agreed na to. Okay? Yan. So again, this domain, restricted domain, becomes the range, and the range of tangent, which is negative infinity to positive infinity, the domain for the inverse. So graphically, let's draw the graph. We have for y equals tangent x on the interval x, on the interval negative pi over 2, open interval negative pi over 2 to pi over 2. So let's draw the graph. Actually, this is one period, no? So the graph at one period. Okay? So I can now have here the asymptotes. It is asymptotic at pi over 2. Let's say this is pi over 2. And also, sa negative pi over 2, it is also asymptotic at negative pi over 2. X equals negative pi over 2. X equals pi over 2. When x is 0, arc tangent is 0. When x is pi over 4, tangent is 1. Let's say this is 1. So it goes here. And then asymptotic supposed to be here. And then it goes here. Asymptotic here, no? Yeah. So that is how it looks like. Okay? That is for y equals tangent x restricted on this interval. What about for the graph of its inverse? Tangent inverse of x or arc tangent of x. So this vertical asymptotes becomes the horizontal asymptotes for the graph of the inverse function. We have pi over 2, negative pi over 2. So asymptote okay. I think I need to lower more. And here. Okay, so that is y equals negative pi over 2. While this is pi over 2. Which one? This one. Y equals pi over 2. Okay, guys? So let's have the graph. If xz is 0, arc tangent of 0 is 0. When x is, let's say, 1, that is pi over 4. Let's say it's somewhere here. And if it is, let's say, negative 1, arctan of negative 1, it's somewhere here, negative pi over 4. So the graph is asymptotic to y equals pi over 2, asymptotic also to negative pi over 2. Okay, so that's the graph of inverse tangent. Any question, guys? Evaluate. Number 1, tangent inverse of 1. What is that angle? If I take the tangent, it is equal to 1, pi over 4 or 45 degrees. Number 2, what is that angle? If I take the inverse tangent, it is negative square root of 3. So that is negative 60 degrees or negative pi over 3. We take it in the fourth quadrant, but negative angle. So because in the restriction, y is supposedly between negative pi over 2 to pi over 2. So if negative, it is in the fourth. If positive, it is in the first. Number 3, arc tangent of negative is square root of 3. Negative is square root of 3 over 3. So this is equal to, what do you think, guys? Oh, guys, what do you think? Guys, do you have any suggestion for the value? Huh, guys? Guys, this is negative 30 degrees. Not 30 degrees, huh? Negative 30 degrees or negative pi over 6. Okay? Yan. Number 4, arctangent of negative 1. So that is negative pi over 4 or negative 45 degrees. In calculus, it is possible for you to meet this, no? Let's say as x approaches negative, positive infinity first. Positive infinity, what happens to inverse tangent of x? It approaches pi over 2. Equivalently, we write that in calculus as limit as x approaches positive infinity of tangent inverse of x is equal to pi over 2. Okay? If you have as x approaches negative infinity, then tangent inverse of x is what? Approaches negative pi over 2. Okay, guys? Then, if we, in terms of limit as x approaches negative infinity, arctangent of x approaches pi over 2. Okay, negative. Negative pi over 2. Next, we have number 4. So this is letter D. Inverse cotangent of inverse cotangent function. Okay? Inverse cotangent function. So, given, again, y equals cotangent x, for this to have an inverse, we need to restrict x between 0 to pi, which is similar to the restriction on cosine x, no? Except that we don't include endpoints. Again, why? Because endpoints here at endpoints, cotangent is undefined. So x equals 0 and x equals pi serve as vertical asymptotes for cotangent x. So its inverse is given by or is defined by y equals COT with superscript -1 of x, read as inverse cotangent of x, or y equals arc cotangent of x. Now, this is true if and only if cotangent of y is equal to x. So let's say you have to take cotangent of y and you must be able to get the x. But of course, for all y, that is between 0 to pi, open interval 0 to pi. So this restricted domain becomes the, for cosine cotangent x becomes the range in the inverse cotangent x. Okay, so what's the domain for the inverse? The domain is negative infinity to positive infinity. The range is given by open interval 0 to pi. For the graph of cotangent, the restricted cotangent and its inverse, so we have y equals cotangent x, where x is between 0 to pi. So we have this graph. The graph of tangent and cotangent, for me, they look like sexy, no? The way I look at the graph, it's a sexy graph. I don't know how, but I look at it as a sexy graph. For cotangent, I think we need mostly in the first quadrant. Because 0 to pi, no? And fourth quadrant. Yan. So this is x, this is y axis. So 0 to pi, let's say this is pi. And of course, vertical asymptote is at pi, x equals pi, and at x equals 0 or the y-axis. This is pi over 2, the middle one. Pi over 2. Okay? So the graph is asymptotic to the y-axis and asymptotic also to the pi over 2, no? So remember this graph, no? So that's for the tangent, cotangent. For the inverse, the graph is given by this. So for the inverse of cotangent of x, or y equals arc cotangent x, so we have this. So we have pi becomes here, and that is the horizontal asymptote. The y equals pi becomes the horizontal asymptote, which was before. This is the x equals pi, no? So it is now y equals pi for the inverse. And the x equals 0 now becomes the y equals 0 in the inverse, which is also asymptote. Okay? So let's say this middle is supposedly pi over 2. The graph is asymptotic sa pi and then sa 0. So passing through this middle. And here, let's draw the orange using orange. Here. So asymptotic to, yan, here. And asymptotic here. Okay? That's how it looks like, approximately. If, for instance, if x is 1, you have pi over 4. So the point is somewhere here. If you have negative 1, the point is supposedly in the second quadrant. So that is negative, of negative 1. So that is 3 pi over 4 in the second quadrant. This is 3 pi over 4, somewhere here. Okay? So that is 3 pi over 4. So this is pi, no? So that is pi. Okay, guys? That's the graph. So again, so let's have for the evaluation. You know already how it looks like, how it is written mathematically. This is the name. This is how it looks like. And this is how it operates, no? Cotangent inverse of is square root of 3. What is that angle? If I take the cotangent, it is square root of 3. So that is pi over 6, or that is 30 degrees. Number 2, arc cotangent of negative is square root of 3 over 3. What is that angle? If I take the cotangent, it is negative square root of 3 over 3. So we take it in the second quadrant. So the reference angle is 60 degrees. So that is 120 degrees, or 2 pi over 3. So that is the value of our cotangent of negative square root of 3 over 3. Number 3, if I have inverse cotangent of negative 1, so it is in the second quadrant because negative. So the reference angle is actually pi over 4, or 45 degrees. So that is 135 degrees, or that is 3 pi, no? 3 pi over 4. Am I right? Okay, so that's in radian measure. No? Okay, guys. 4, we have cotangent inverse of 0. What is cotangent inverse of 0? Guys, when x is 0, what's the value? Pi over 2. Right? If x is 0, what is the angle? Pi over 2. So again, in calculus, we normally encounter things like this. As x approaches positive infinity, what happens to cotangent inverse of x? So that approaches 0. As x goes to the right, the y value is getting closer and closer to 0. So that is, in terms of limit notation, as x approaches positive infinity, cotangent inverse of x is equal to 0. As x approaches negative infinity, so we have cotangent inverse of x approaches pi. No? As x goes to the left, y value increases, but limited to up to pi only, no? So approaching pi. So it does not go beyond that. So that's the limit, no? So negative infinity, limit of cotangent inverse as x approaches negative infinity. So that is equal to pi. Okay? That's how we write it in calculus. A question, guys? Guys? We're now on letter E. Inverse cosecant. Inverse cosecant. We have a problem here. Inverse cosecant function. The problem is many authors or mathematicians don't agree on the restriction, common restriction for the inverse cosecant. It depends on their objective, no? So they have their own objective. The reason why they differ in the restriction for the cosecant to make it 1-to-1. Okay? So one restriction that is commonly used, but not all are using this, no? So to have an inverse for y equals cosecant of x, so we restrict it to what? We restrict to x equals a union of intervals 0 to pi over 2, half open interval, closed from the right, union with negative pi, half open, half closed interval, negative pi to negative pi over 2, close from the right. Yan. So this is read as open interval 0 to pi over 2, open from the left, or half close interval 0 to pi over 2, close from the right. So union of this and this, union of this and this. So first quadrant and third quadrant. Kaya lang sa third quadrant, our angle, the rotation is clockwise. We don't rotate counterclockwise. Pag counterclockwise to go to the third quadrant, so you will get pi to 3 pi over 2. But this is negative pi to negative pi over 2. So that is from, in clockwise direction, third quadrant. So as I said, the different authors have different restriction for this, no? There are authors who restrict it 0 to pi over 2, no problem for the first quadrant. They differ in this quadrant. 0 to pi over 2, then pi over 2 to 0. Actually 0 to pi over 2. I mean 0 to pi. They have 0 to pi. Merong ganon, no? Pero tayo, negative pi to negative pi. Meron namang pi to 3 pi over 2 dito sa second interval. So this is what we're going to choose. This is what Lighthold is using, Okay? We in the math depth, in the LSU, unfortunately, parang we don't have uniform interval chosen for this to be 1-to-1. So merong iba yung reference nila rito. This is what I use. In Ateneo, what is nice in Ateneo is that all of them, they agreed on one restriction only. So perhaps they met and agreed on this, no? And this is what they use. Okay? So all of them, so that they have uniform answer when you take the inverse cosecant. But in our case here, we have our own, and this is what I follow. Okay? So if you ask of other sections, perhaps they have different restriction. I will explain to you later why I chose this, no? And why others chose a different version for the restriction. y equals for the inverse, cosecant inverse of x, that's the notation, or y equals arc sine, arc cosecant of x, yan. If and only if, so this is true, if and only if cosecant of y is equal to x. These are actually the same, no? As long as your y is on the interval 0 to pi over 2, this open interval 0 to pi over 2, open from the left, union with open interval negative pi to negative pi over 2, open from the left. So if we restrict y to this intervals, then this is true, no? So cosecant y equals x means y equals cosecant inverse or arc cosecant of x. So what's the domain? The domain is the range of cosecant. Ano ba yung range ng cosecant? Ang range is negative infinity to negative 1, union with from 1, including 1 to positive infinity. So that's the range for cosecant, which is the domain for the inverse. And for the range, of course, we defined that. We agreed on that. Open interval 0 to pi over 2. Open from the left. Union with open interval negative pi to negative pi over 2. Open from the left, no? Yeah, that's it. Okay, guys? Any question? What about for the graph? So for their graphs, so graphically we have for y equals cosecant of x, which is restricted on this interval 0 to pi over 2. Let me move a little here. Union with negative pi to negative pi over 2, close from the right. So this is how the graph looks like. Y we have negative 1, positive 1. Let me make it longer. Negative 1, positive 1 here. And then we have pi, sorry. This is supposedly pi over 2, 0 to pi over 2. And then negative pi over 2. This is negative pi over 2. Negative pi over 2. 2 to negative pi. Yan. What's the asymptote? Asymptotic sa x equals 0. Asymptotic also sa x equals negative pi. In this restriction, asymptotic to these values, no? Negative pi, x equals 0, vertical asymptotes. Now, the graph of cosecant, let me make it longer. I think I have to make it longer. The y-axis. Ay, sorry. I am going to make it longer. Yeah. And this one, let me put it down. Okay. So this is asymptote, vertical asymptote. So this is 1, this is -1. If x is pi over 2, we have y is 1, cosecant pi over 2, 1. If negative pi over 2, the x, -1. The cosecant, the graph is above the graph of y equals sine, no? X, the graph of that. So, but we want it from 0 to pi over 2 only. Asymptotic here, so something like this. So we don't draw anymore the graph along here. So, and then asymptotic here, okay? So that is the restriction, no? Some has a restriction to the right of negative pi over 2 to be 1 to 1 and together with this. But in our case, to the left of negative pi over 2. So that's what we agreed, or we are going to agree. Okay? So for the inverse, y equals cosecant inverse of x, or y equals arc cosecant of x. So this time, these vertical asymptotes become horizontal asymptotes. Okay, guys? So we have this axis here. Let me move this a little upward. And let me move this a little upward also. So this is y, and then x here. So the range now is the domain here. So what's the domain? This restricted value that becomes the range in the inverse. So 0 to pi, 0 hanggang pi over 2, I mean. Ito yung pi over 2. Then negative pi over 2. Negative pi over 2. Ito yung negative pi. Negative pi. So asymptotic saan? Sa negative pi, asymptotic here. And also sa y equals 0. Okay? So this is asymptote, y equals 0, and then y equals negative pi. Where in the cosecant, they are x equals 0 and x equals negative pi. Okay? So let's take the inverse of this part. For this part, so if you have 1, if x is 1, if x is 1, so here is 1, no? Let's say it's -1, -1, +1. If x is 1, pi/2, the output. Inverse cosecant of 1 is pi/2. If x is -1, -pi/2. Then, asymptotic sa y-axis. Ay, sorry. Asymptotic saan? Sa x-axis. So, something like this. So, that's how the graph looks like. And then here, asymptotic naman sa -pi. It's not nice. Okay, that's it. Yan. Okay, so that is the inverse for this. Notice that the inverse is also 1-to-1, of course. So if you're asked of, now by the way, in calculus, this is very useful. In calculus, you will be encountering formula like this, no? So if you are already in basic calculus, you ask your teacher. This is very important so that you will not get lost, no? So in calculus, we encounter this formula. So that is actually one of the objectives why we choose this, no? Or why other authors choose this restriction. If you have a derivative of with respect to x, so I'm not really sure if you are familiar with this, but let me introduce this to you. Of cosecant inverse of x, we have -1 over, so -1 over x is square root of x squared minus 1. Okay? So that's the derivative. What's the significance of this restriction on this formula? So in this formula, I don't need to put absolute value, because if you're going to check books in calculus, there are books that have absolute value here. Like for instance, -1 over the absolute value of x is square root of x squared minus 1. But if your restriction is -pi to -pi/2 on x here, which is the restriction in the range here, in the inverse, if your inverse function has a restriction on y, which is -pi to -pi/2 union with 0 to pi/2, then this is the formula that you're supposed to have in your calculus. But if you don't have this restriction, the other way around, this is supposed to be the formula that you must have. So you have to be consistent. So let's say when your teacher asks, when you ask your teacher, so teacher, what is the range for cosecant inverse of x? If your teacher says 0 to pi/2, it's like 0 to pi, like this one. 0 to pi, yan. 0 to pi. So some books use this, no? This is supposed to be the formula that you're supposed to use. But if your teacher says this is the restriction and he or she has this formula, there is a conflict, meaning he or she doesn't understand the consistency, because this formula belongs here. This formula belongs to this restriction. Okay? O kaya naman, pwede rin dito. Ito, nag-a-agree din yan sa 0 to pi over 2, katapos union with pi to 3 pi over 2, which is also in the third quadrant. Yan. If this is your restriction, okay pa rin. Ito pa rin yung formula that you're going to use. But this is the one that I followed in Lighthold. Stewart's calculus, I think, is following this. But it has to be this formula also, okay, in calculus. So you must be consistent, or you must be what you call this? This must agree with the restriction. Otherwise, this is not correct. Look at this. What do we mean by derivative is slope? So if x is positive, look at the graph of inverse cosecant. If x is positive, meaning to the right of 1, actually, to the right of 1, that's what we input, to the right of 1. So this is always negative. So Ken, if you input to the left of to the right of 1, so this is always what? This is always positive, this value, which is actually the slope. And if you're going to draw the tangent line to this graph, the slope is rising. The line is rising, rising up to the, to the left, no? So negative the slope. If you look at it, it agrees here. If x is negative here to the left of -1, so draw the tangent, the slope is positive, which is agreeing here. Negative, negative, positive. But let's say this is your restriction. But this is your formula. But this is your formula. Ito yung restriction mo, pero ito yung formula mo. Wrong, no? It doesn't agree. Because this is absolute value and this quantity is always negative. But if you check, if x is to the right of 1, negative ang slope, but this is always negative, no? So correct for this case. But what about if you are here? Positive ang slope, but this is always negative. It doesn't agree anymore. So the derivative means slope and it doesn't agree. Okay, so this restriction agrees here. And this restriction agrees here. Okay? Yeah. You have to check that. And we're going to have such restriction later. No? So I will explain to that for the other restriction. That is one objective of an author in calculus or in Trigo who has a calculus book also. The reason why he is using this because the formula that he is using for calculus is this formula. Okay? Yeah. So again, this is true when your x is what? Your x is between -infinity to -1, but this time open because this is derivative. Because the derivative does not exist when x is -1 or when x is 1. 1 to positive infinity. So this is the restriction for the derivative. Huh? Ny here, or the cosecant supposedly. Cosecant inverse of x is between what? Is between negative pi to negative pi over 2 union with but of course we don't include negative pi over 2 no for the derivative because we don't include -1 union with 0 to pi over 2. Sa pi over 2, the derivative does not exist at the end point. You will have this, no? Why it is non-existent, the value at the end point. Okay? So that's the one objective why you have this restriction. So let's have evaluation. Evaluate. 1. We have cosecant inverse of let's say square root of 2. What is cosecant inverse of square root of 2? If you have like this, ask yourself, what is, you take the reciprocal, what is an angle, what is the angle whose sine is square root of 2? So that is 45 degrees. So, 1 over square root of 2, 45 degrees. So, sa cosecant, pag square root of 2, 45 degrees. the inverse cosecant, or that is pi over 4, which is in this first quadrant. Okay? So, or you should have memorized the values of special angles. If you have negative square root of 2, what angle in this quadrant? That is negative 135 degrees. Look at the value, huh? Negative 135. In other section, they might have other value because they might follow a different restriction in the third quadrant. No? So there are, perhaps they might be in first quadrant and second. Tayo first quadrant and third. So negative 3 pi over 4. Okay? Number 3. Cosecant inverse of negative 1. That is negative pi over 2. Okay? If I have number 4, cosecant inverse of positive 2. So that is in the first quadrant because this is positive. That is, if positive 2, reciprocal is 1/2, no? Pag sine, 30 degrees. So this is 30 degrees. Cosecant inverse of 2, or that is pi over 6. Okay, guys? Number 5, if I have cosecant inverse of negative 2 square root of 3 over 3. Actually, the reciprocal of this is negative 2 over square root of 3. No? If you have, square root of 3 over 2, negative square root of 3 over 2, the reciprocal. And that for sine, no? For sine inverse. Kaya lang, pag square root of 3 over 2 negative, doon tayo kukuha dapat saan? Sa third quadrant. So ano yung angle? Ang reference ay 60 degrees, nasa third quadrant. Negative 120 degrees. Okay? That is the reference angle niyan, negative positive 60 degrees. Or that is negative 2 pi over 3. Okay? That's it. So that's for what? For cosecant inverse, no? So the other version of this, let me explain to you. The other version. Other version. Other restriction. But we're not going to use this. So again, this is not what we consider. We don't consider this. We don't consider this. I will just explain it to you why we don't consider this. Hindi ito yung ating i-adapt. Other restriction. We have, so as I said, yung iba, ang restriction is what? Ano yung restriction ng iba, guys? 0 to pi, no? So you have y equals, ang restriction niya is 0 to pi. Yung iba naman, I think, negative pi over 2 to pi over 2 rin, no? It depends on what you call this, the author, no? And its objective. So let me check. I am opening a book. What other book is using as a restriction? For the other one, I don't have a copy of the book here. So let's see. Cosecant, this is the graph. Okay, so that's the graph. So cosecant, I think yung iba is using this, no? where x is, I think, negative, they use this one, negative pi over 2. Yung iba 0 to pi, yung iba negative. Pag 0 to pi, I am not really sure pag 0. But what I know, negative pi over 2 yung others. No? Because I'm not using this, that's why I'm not really familiar. Negative pi over 2 to pi over 2. This restriction, where x is not equal to 0. We are going to remove this in this interval. So this is the other version. So negative pi over 2 to pi over 2. So this is 1. This is negative 1. So the graph is supposedly here. No problem in the first quadrant. No? So we'll have asymptotic here. Asymptotic sa y. Okay? Axis. So that's it. It's not a nice graph. It's something. And then for the other one, negative 1 here, common. And then asymptotic sa y pa rin. So this is what others do, no? Yan. And notice that if you draw tangent, tangent, always what? Always positive ang slope. There is ay negative ang slope. Always negative in whatever portion of the graph you draw. That's why in calculus, the formula for the derivative that they have, this is for y equals, no? For y equals, sorry, this is for cosecant, no? Ay, nagkahalo-halo na. This is for cosecant x. So that's what we restrict. And for the inverse, yung inverse niya, almost time, y equals cosecant inverse of x. Ang restriction naman natin ay sa y, ito rin, no? Yan. Negative pi over 2 to pi over 2, but we assume x not equal to 0. So graphically, this is what we get. This is negative pi over 2. This is negative pi over 2. But the asymptote is somewhere here. Then the restriction that they follow, this is negative 1, for instance. This is positive 1. So here, asymptotic sa y, magiging asymptotic sa x. So something like this. Yan. Look at the graph. The slope is always what? If you draw a slope, always positive, negative here. And then here, so this is when x is negative 1, this is positive 1. So we have asymptotic also here. No, not there. Dapat sa x-axis. Kasi sa y, magiging sa x here. Yan. Okay? Yan. Notice that the graph has always a slope that is also negative. Okay? Negative ang slope in both portions. Therefore, in calculus, if you're asked of the derivative with respect to x of cosecant inverse, dapat your formula is negative 1 over absolute value of x. Pag hindi ito yung formula nyo at ito ang restriction nyo, hindi nag-agree ang inyong restriction ng cosecant inverse sa derivative. Ibig sabihin, the teacher does not understand the consistency of this. Because this is always negative, because the denominator is always positive, numerator is negative. Whatever your x is, whether negative or positive, this is always what? I'm in a hurry because go almost time. So this is always negative. So you look at the graph, the slope is always negative. So this is interpreted as slope of what? Slope of cosecant inverse, cosecant inverse of x, no? Slope of cosecant inverse x. So that's what we mean by derivative, the slope of that. So at this point, for instance, the slope is negative. Here, negative, always negative, wherever you draw, because rising up to the left. Okay? So this is always negative. Unlike here, in our previous one, look at the graph. So the graph, the tangent is positive here, negative here, because if x is positive, negative, the derivative. If x is here, negative, the slope is positive because negative, negative, positive, or it agrees. Okay? But if you put absolute value, it does not agree here. So, but in other case, dito naman, pag ang inilagay mo naman ay walang absolute value, pero ito yung iyong restriction, wrong. No? So, that is wrong. This is why I am wrong. Who is perfect? God. So, y is not equal to 0. Kasi this is y. Okay, hope you understand this, guys. Okay, guys? So, I will continue. And then we'll also have a restriction in the secant and cosecant, inverse cosecant, I mean. Any question, guys? Kaya pag itong restriction, ito dapat ang formula sa calculus. Pag yung isa, walang absolute value sa derivative. You check calculus books o mag-Google, tingnan niyo kung ano yung formula sa derivative. Pag ito yung restriction. O kaya pwede ring pi to 3 pi over 2. Ito hindi nagbabago yung slope. Nag-agree pa rin. No need for absolute value. Lighthold chose this so that he doesn't need absolute value in the formula. While others, kasi ito ang pinili nila, kaya wala silang choice kundi mag-absolute value para mag-agree. Okay, guys. If you don't have questions anymore, so you can now leave. So dismiss. That's it.